The size of our solar system is almost beyond human comprehension, stretching across billions of kilometers and containing a variety of celestial bodies that range from tiny asteroids to massive gas giants. Our solar system formed about 4.6 billion years ago from a collapsing cloud of gas and dust, and today it consists of the Sun, 8 major planets, dwarf planets like Pluto, countless moons, and other small objects such as asteroids and comets. At its center lies the Sun, a glowing sphere of plasma that makes up more than 99.8% of the system's total mass. The immense gravitational pull of the Sun holds all the planets in orbit, defining the boundaries of the solar system. To truly understand its scale, it helps to look at the distances between the planets and how enormous those gaps really are. The average distance from the Earth to the Sun is about 150 million kilometers, which astronomers call 1 astronomical unit, AU. Each planet lies farther away from the Sun in an almost exponential pattern, meaning the space between planets grows rapidly as we move outward. The inner solar system, which includes Mercury, Venus, Earth, and Mars, is relatively compact compared to the outer regions. Mercury, the closest planet to the Sun, orbits at just 39 cents, around 58 million kilometers, and completes one orbit every 88 Earth days. It is a small, rocky world with extreme temperature changes, baking in sunlight on one side and freezing in darkness on the other. Next comes Venus, at about 108 million kilometers from the Sun, often called Earth's twin because of its similar size and mass. However, Venus is shrouded in a thick atmosphere of carbon dioxide that traps heat and raises its surface temperature to over 460 degrees Celsius, making it the hottest planet. Earth, our home, orbits at 1 AU from the Sun and is the only known planet to support life, with liquid water and a protective atmosphere. Mars, the red planet, lies about 228 million kilometers from the Sun, or $1.50 away. It is a cold desert world with enormous volcanoes and canyons, and though smaller than Earth, it has captured human imagination as a potential site for future colonization. Beyond Mars lies the asteroid belt, a vast region filled with rocky debris that never formed into a planet due to Jupiter's strong gravity. This belt marks the transition to the outer solar system, which contains the gas and ice giants. Jupiter, the fifth planet from the Sun, is by far the largest, more than twice as massive as all the other planets combined. It orbits at $5.20, or roughly 780 million kilometers from the Sun, and has a diameter of about 143,000 kilometers. Its swirling clouds, giant storms like the Great Red Spot, and its system of nearly 80 moons, including the volcanic Io and icy Europa, make it a world of incredible complexity. Saturn, famous for its magnificent rings, lies about $9.50 from the Sun, or 1.4 billion kilometers away. Though less dense than water, Saturn is a massive gas giant with more than 140 moons and moonlets. The next two planets, Uranus and Neptune, are known as the ice giants because of their colder atmospheres rich in water, ammonia, and methane. Uranus orbits at about $19, 2.9 billion kilometers, and has a unique sideways rotation, while Neptune, the most distant planet, circles the Sun at roughly $30, or 4.5 billion kilometers. One orbit of Neptune takes 165 Earth years to complete. Even at Neptune's distance, the solar system is far from over. Beyond it lies the Kuiper Belt, a region extending from about 30 to 55 Australian dollars, filled with icy bodies, dwarf planets, and comets. Pluto, once considered the ninth planet, resides here, orbiting the Sun at an average distance of 39 Australian dollars, 5.9 billion kilometers. Farther still lies the scattered disk and the hypothetical Oort cloud, a vast spherical shell of icy remnants that may extend up to 100,000 Australian dollars, or roughly 15 trillion kilometers from the Sun. This distant region marks the outer edge of the Sun's gravitational influence and the boundary between our solar system and interstellar space. To put that in perspective, light itself takes more than a year and a half to travel from the Sun to the outer edge of the Oort cloud. Even the fastest spacecraft ever launched by humanity, Voyager 1, traveling at over 60,000 kilometers per hour, would take tens of thousands of years to reach it. The immense size of our solar system reminds us how small our planet truly is in the cosmic scale. From the scorching surface of Mercury to the frozen outskirts of the Oort cloud, the solar system spans a space so vast that distances must be measured in astronomical units or even light years. Each planet and region tells a part of the story of our Sun's formation and the evolution of matter in space. The solar system is not just a collection of planets, it is a sprawling, dynamic arena of celestial motion, gravity, and time, stretching across billions of kilometers and billions of years, offering humanity a glimpse into the vastness of the universe itself.